Hi guys, and in this video we're going to learn about linear regression. As I said in the earlier video, where I just introduced it all, this is machine learning for kids. I'm saying that in this video. And we want to learn all the basics of AI before actually getting to you know, the making of the video game. That's quite complex, right? And we might just want to add lots of AI in it, not just movement and shooting, maybe even socializing. So yeah, and this is a place where they've just you know said all the maths. They've explained the maths of linear regression. We're gonna have a plot like this, and we want to make the line of best fit. That's what linear regression is all about: making the line of best fit, computing it. And that helps because you can predict things. you know hey, this is how the line is going, so what will the seventh x thing be in the y place. It's useful in many areas. I just can't explain it. Go back to your math classes maybe and remember where x and y are used extensively, and you can use linear regression there. I actually used it to predict whether PewDiePie or T Series would win in their battle, but well, didn't work because it's not that accurate, as you can see. This is where I have explained everything in code, Python. And what we want to do is not just like we want to translate all of this to JavaScript, okay? And no, we aren't using any Babel or something. We're not using Babel or anything else. We're going to go straight to Atom, which is, I don't know if you can see it or not, whatever. And we're going to translate the whole thing to JavaScript, but that's later on this video because we want to actually understand this code, right? I mean, school code. Yeah, JS is not BS, okay? JavaScript is not BS. I'm not saying that. Bad words. Okay, so in this import section, we have random, matplotlib, and maths. We're importing random to generate random data. You see, we don't have data. We don't really go around asking people for things. That takes too much time and maybe money for printing and advertising. Matplotlib, it's just basically this graphing library. I am not really, I don't know it as well as I should, but I know the basics and I can teach you that in this very video. We want to visualize our data, right? Examples are these. Um, Now we want to also import math because, as you can see here, all these formulas do require math, especially square root. Where is that? Well, calculating mean, median, standard deviation, yeah, you need square root, okay? And I think you need it in correlation. I wrote this notebook like a month back, so really, I don't remember any of the formulas, but I do remember what linear regression is and I can understand my code, okay? So, yeah. Um, Oh, I almost forgot saying this. It's my third time I've taken this video, so well, let me say. Collaboratory is this scientific notebook that literally just lets you. It's for data science, and what we're doing right now is data science, no less than that. Um, you see, you can write, you know, anything describing your code, can make it into like small points, can make it into really small. You can make it into several different blocks and develop like that. I don't really like writing like lots of code at once, although I really like writing lots of code for no rhyme or reason. I don't like reducing my code, really. So let's get to the start of this and understand this part, right? Control slash any kind of variables that you be declared. Really, these are all just very fancy ways of saying that these are the variables that I'm going to declare here. I don't want to declare my videos variables anywhere else because, well, I don't like doing that. and it's just very nice to set apart local and global variables, if I have any local variables in this whole thing. Whatever. Mx stands for mean of x. You know, mean of the x values. Mean is average, so the average of x values. That's basically like, for people who don't know what average is, because basically this is machine learning for kids. Average is basically the you know I can't explain it. Just Google it. Mean of y, the average of y. Google that as well. Average of the y values. Really, I just wrote these brackets indicating what these are for no reason again. I just like looking at them. Standard deviation of x. Yeah, this is a good bit. It just shows how much x deviates from its mean. Like deviate meaning uh, how much it doesn't include. I mean, how much it it's not like the median of x. This is basically the way we score all our values. We score the whole model, right? I mean, we score all the data. It's like some kind of loss. It's as I said, the score. How how much loss is there between the mean and the standard deviation? This again is averaged, and the average of the deviation is a standard deviation. Okay. Pearson's correlation. That's R right here. Um, that's basically like, is it negative? Is it positive? I mean, should the line of the graph be negative or positive? This is negative. This is positive, unless I'm actually blind. Yeah, this seems like positive. This is negative. Um, yeah, that's basically what Pearson's correlation tells us, and it also tells us, other than negative and positive, how much of a correlation the data has, so we can see, good at computing the gradient, right? It's very useful there. That's where the Pearson's correlation comes. M is the gradient, which we're trying to find in this video. M and C, that's all we need. M and C is what we're trying to find, and the rest are just ways to find it. M is the gradient, gradient. Really, you should have learned the equation of a line. I mean, I'm not trying to teach machine learning to toddlers, so yeah, I'm not going to explain that. Yeah, we're trying to the gradient, and M, which is a y-intercept. Yeah, this is the y-intercept, right below 80, above 60. That's C, the y-intercept. So we just explained two things at once, two variables at once. Now we want to find out, we want to explain what y and x is. Not we, just me. Y is the y values, x is the x values, as simple as that gets. X dev, x deviation, the standard deviation, no, the deviation, that multiple deviations of x, and y dev is the multiple deviations of y. XY deviation is x into y and deviation of xy. We'll get to that later onwards. Actually, I'll look here. What's xy deviation? I actually think that's in correlation. Let's just go there. Let's hope you can see this. Really, I don't know how this thing captures everything. Ah. I'm so sorry, I'm going so fast. I guess this is deviation of x. Why do I not see everything? X, Y dev. X deviation values and Y deviation values. Thankfully, I read this, or else I would have been lost forever. X deviation values and Y deviation values give X, Y dev. It's an array because, see, we need to say every single X deviation or Y deviation. I hope you understood that. You know what, I think I'll just link this whole thing to my YouTube video. I don't think my explaining skills are really that good. So yeah, that's X, Y deviation. X deviation square. Let's just read this. Okay, so these are just the x deviation values squared. All these values, every single one of them squared and put into this array. Y deviation value squared, same as x but just with y. Now we've explained all the variables, we'll see how we get them. So first we have to generate the data, um, like this. Yeah, just like this. Okay, start, stop. That's that's like basically the range of data we want. If we want the range to be from like 100 to 1000, then we'll write start as 100, stop as 1000. And this is basically a loop that generates the data. And here is finally the visualization of the data. You see, this is just like a glitch or something on collaboratory that I got two graphs. It's actually meant to be one. You know what, I'll just run the whole thing again. Unless it's not a glitch. Hey. This thing right there, I don't know if you can see it, but this is the recording spot. I'm just waiting till this whole thing connects and everything. Whatever, till then I'll just explain this. PLT.scatter x and y. So we take in the x values from this right here. You see x and y array, and you make a scatter plot of them like this. This is the scatter plot. Yeah, basically, but we want to show that plot, don't we? We want to show it on the screen. So what we do is we show. This function is there because you see you don't want the like graph to generate it, like right when you say scatter. You might want to include like a line graph as well to show this is the scatter graph, this is a line graph. You know, to maybe show the points or like this, maybe this. You know, you want to show the linear regression line, the regression line. That's what I call it now. Maybe lots of other people have called it. Ah, look, finally found the emojis here. Now this is the tricky bit. The calculations. This is all actually the mean part's quite easy. Just find the mean of x. I'm sure we can do that. You just find the mean of x by first you add up all the x's to mx, you know, every single x value, and after that you divide it by the length of x, and then you show it. This is the mean of x. Okay, look at this, and then look at this. Now you see the truth. Finally, the truth. Python never lies. Now we loop through y and we get the mean of y. Same as x but with y. Look at that. Look. This is the mean of y. 47.4. Now we want to find out the deviations. Right. This is like really fancy syntax I learned from some kind of tutorial. Yeah, I just want to show them till 4. So what is the x deviation? Yeah, the x deviation is basically well, the values of x minus the mean of x minus, and the values of x minus that. Okay, so well, we have this. So what was the starting? Did we show it? We just showed it in a scatter plot. Well, we don't know what's the first and last thing, but well, you see this is the deviation in many of them. One is a minus 30.5 deviation, another one is a 42.5 deviation. Well, yeah, read this, okay, read this, please comment, I'll get money. After that we do the same thing with the y values. Yeah, same thing with the y values, y deviation values. Now we want to multiply these values to get xy dev. The one that I was so confused about is finally understood. The truth has come out again. Python never lies. Python, not BS. That doesn't rhyme. Let's think of something. No, I just can't think of any other rhyme to do with Python. Well, we are done with x and y dev. Now we want to figure out this. What is this? Yeah, this is where we need math, the library for math. I'm not very good at editing, so I'm just gonna, give all the effects on the video. Math. Yeah, so the the formula for this, many people don't understand like from code, nor do I. So let's just go and look at the formula. Visual learning. The formula for standard deviation. Open link a new tab. What? So sorry. Open the wrong thing. Oh no, I opened the right thing. Okay, now. Come on. Yeah. What? This makes no sense. Okay, so this is the x value minus the mean of x, and we want to square this. And see, standard deviation square. Just use simple algebra. I mean, this should be. You know what? This doesn't explain standard deviation that well. I'm just gonna search it on a different tab. Standard deviation. Probably because of all the games I've been playing. My spelling has gone wrong. You know what? Formula. Just search engine, man. Standard deviation formula. Yeah. See, this O thingy, lowercase sigma, that just means standard deviation. Don't pay much attention to it. N is the length of the array I have, just number of values, and this thing right here, capital sigma, is just like, add up all the values together. That's what it means. Add up every single value, like we did in the mean of x, before dividing it by the number of values they had, and you minus the x value from the mean of x, and then you square it. Have I given that? Have I done that? Have I? Yes, I have done this. It makes me wonder, why do you actually like square it and then square root it? I think it's because, maybe you just want to make it, positive. Could have used absolute. Data science, really. From my age to wondering can get me mad. Really, it is. Whatever. Ignore that statement I just made. It's very bad. Yeah. Let's just understand this. We square root this thing right here. You know what? I'm just gonna comment something. Make a comment. Like you're gonna comment on my video. Hopefully, if there are any views. Yeah. So sorry, that was just an earthquake. So you square root, let's just sqrt, and then you make a bracket, and then you make another bracket, to show this thing right here. Okay, so well, you want to minus x value from the mean of x. Actually, it should be other way. Stop talking so fast, Arjun. Mean of x. Okay, so you found the deviation. Now you will just make a square of it. Okay, just square the deviation, then square root it. Okay, so that's what the loop does. And man, why isn't this? Yeah, now the square root. Oh, now, well, we figured out what the loop does, and now what we're going to do is, find the standard of the deviation. So that's just dividing the standard deviation from the length of the values of x. And then let's just show it. This is the standard deviation, 25 of x. See, another piece of truth just comes out. Another truth. I love truth. And now we do the same thing with y. I mean, I just explained it, so you'll understand it. If you don't understand it, I'm going to say the same thing as I say so many times. Google it. This is the standard deviation of y and x. It's similar, don't you think? Quite, for some odd reason. Oh, I actually I linked an image here. Yeah, see, why did I even like, that's for R. I don't think I did anything for standard deviation. So now is the trickiest bit of the tricky bits. That is finding the correlation. The rest of it is just like donkey's feet, if you think about it. Just made up something. Oat the goat. Such a nice name. R is the correlation, that's the sum of x into y. So that's what's that. Let's just read this. Yeah. Remember that x, y deviation values we had right here? Same thing that had me confused. And we just calculated it like a while back. I remember that as well. So that's basically what you have to do. You have to make a sum. You have to sum up all of them. And you have to get one sum. And you put that on top as a numerator. Remember your math lessons. Numerator. And then square root the sum of the x square and the y square. You know, x deviation square and the y deviation square. Did I actually show myself doing that? Let's hope so. Ah, yeah, I did that. I didn't show it to you guys. Okay, fine. You have to calculate this as well. Remember that. From all the x deviation values, just, you know, append it to the xy deviation values. What? No. This one, yeah. X deviation square. You just multiply. You just square all the x values and put that in an array. Okay. Hope I'm not using any fancy words here, and let's just continue. Yeah. So you have to divide that by the square root of the sum of x deviation squared values into okay, multiplication. What other words are they? I don't know any other words for multiplication. Repetitive addition, yeah. Into y square. Okay, the y deviation squared values. Okay, and then you just square root it. It's all given here, right here. Now let's explain that. The x y sum, you know, these are just some extra variables that I didn't think about when I wrote that. Should we migrate it? No, I don't want to change anything in my code right now. So yeah, the x y sum, the x square sum, y square sum. Basically, like, we want to find this, and this. So the xy sum is the xy deviation sum, the sum of this. Then the sum of this, the x square sum, and then the y square sum. So mysterious. Yeah, so yeah, they're just separate variables to find out the sum first. So they can all be found out in the same loop because they all have the same length. Their arrays have the same length. So yeah, we just add every single value of xy sum, every single value of x square, x deviation square, and every single value of y deviation square. Okay, and then that's gonna come in use in this. Okay, so we want to divide xy sum from here divided by math dot square root. See this right here? Hope you can see my cursor. You have to square root this x square into y square, the x square sum into y square sum, and we have r. Okay, trickiest bit is over. Now we have everything we need to find the gradient, the most important bit according to me. So we multiply the correlation into the the division of standard deviation of y divided by standard deviation of x. What we have here, I mean, if you think about it, it makes kind of sense. I really can't explain this. I mean, the loss of the score of x by the score of y. I was recently watching a video where they actually called this the standard deviation, many times called the loss. They called it the cost. That's actually quite a nice name for it. The cost of x and y. So yeah, you just want to like find the deviations. Think about it, okay? Just think about it. I really can't explain it. Think about it, and you'll understand. It actually makes a lot of sense. Um, well, the formulas are given right here. B is the American way of saying M, okay? And maybe the whole world's way of saying M. Really, I study British words, so that's better. Mm. So, yeah, to find out the gradient, multiply the correlation by standard deviation of I and X. So, you know, I'm not lying to you. Mm. And for this, we have these values as well, you know, mean of Y minus. So, you have to actually find out M first. So, found out M, I got it. C, so, my minus um, m into mx. Oh, it's like I'm going to sleep all of a sudden. No. Um, my is the mean of y minus m into mx. Okay, just remember that. Will you and spare me some explanation? The gradient into mean of x, my. I'm going to explain it. Okay, I want people to watch my video. Uh, so the mean of I minus p and mx. Really, I can't explain it. Figure it out yourself. Okay, I'm not a PhD student. If you're not a kid, then please comment down below, as they all say. So we found out C, and this is M. You see, such a small gradient, and this is C. That's the y-intercept. That's where it all starts. Now we want to visualize the data. We want to visualize the results. And mind you, in JavaScript you won't be able to visualize anything, okay? Nothing. You'll just make it, and it'll be up to you to, you know, think about it, you know, just dream about it. And well, I'll display all the gradients. Mm. So well, you know, we just have a loop to display all of this. We want to make, you know, I have to have a loop to actually form the y and the x arrays. We haven't actually formed them. You see, we only have the gradients, and surprisingly, not surprisingly, I don't know how to, you know, just make a line just based on the gradient in this matplotlib. Yeah, just bear with that, okay? So we found out the x and y arrays, the predicted x and y values arrays, okay, predictions of x and y, and scatter them, plot them. See, that's why you need plt.show at the end, because you want to plot them as well. Who knows, you might want to do anything else much more with it. So in t minus 10, 8, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, we have found it at last, the graph. What is the reward for our work? Feels so good, doesn't it? These are just some random things that I might choose, might not choose. It's up to you to use them if you want to. And well, we've done our work in Python. No, I want this open again. Hey, look at that cute cat. And all those animals come from this side. If this was a war, this would lose, this would win. Oh, one of them just stopped somewhere. That's odd. It's collaborative updates and cats, really, I don't get it. It's like there's some glitch there. Anyways, now let's go to Atom. Yes, we will. I am very sorry that I just gave up on like this, but I would like to say that the next video will be on the perceptron. That's part of the neural network. All that's going to be explained in the next video, so well, that's tomorrow, I guess. Have fun, happy coding. You know what? I've changed my mind, you see, because this atom is not recording for more than 36 seconds. So let's just like wrap this up at just Python because atom's not gonna budge. I have to find a new way to do it. Or hey, we could do it on code that 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 social network for coding. What's that called? Code hub? No. We can do it there. You know what? When we reach there, you'll see. Love. Origin. Not love. Sorry. I am a Dalek. Exterminate. Stop video. Okay, this is like my fourth take of this video, and I figured out why everything is going wrong, why it's stopping in the middle. Okay, I'm not gonna, buy or download some new recorder. The problem is, I'm changing the app. I'm going to like Chrome or Atom. You know what? I'm just gonna stay on CodePen because you guys will all see this and it's very nice, all good. So well, I'm gonna link it and see if I can link it. And I'm not going to go to any other app because I don't want this to stop. Okay, I don't want this to stop. From here on, I've already copied and pasted everything, and we can continue. Yes, we can. We've copied all the variables and everything, and I've already started a loop for data generation, to generate the random data, math.floor, math.random, all that nonsense. And let's just get on with where I left off. Math.floor, math.random, into data range lim. So now we figured this out. Oh, sorry, my sister's calling. Just a second. I have to stop. I am so sorry for that interruption. My sister was calling. Let's get on with the video. Where did I leave? Oh, you know what? I'll just check that right now. Windows plus G. That's how you see everything. Show all captures. Where did I leave off? I have to stop. Not there. Range. Oh, I was still coding then. It's fine. Yeah, so well, we just put all the, finished doing that. Now what we have to do is append these values to x and y. So in JavaScript, sadly you can't use the word append. You have to use the word push. So native. I don't know if that's native or not. Really, I'm not that good at all these things. Y dot push. See, because y is like an array right here, and yeah, let's just put that rand val. Why? You get first pick of the random value. Be thankful. Okay, now same thing. X dot push. So same thing. Sadly, we can't do that. Oh, right, that was a mistake. Control V and well, 2. Hey. And well, 22. Nice. We're just checking something on my keyboard. Now we've got all the data. You want to see the data? Huh? Let's show you the data. Console.log y. Console.log x. And of course we need the semicolon right there. See, this is, why can't this be bigger? I want it to be happier. Yeah, I don't want to see any output at all. Really. Output can go away. I really don't want to see any of that white thing. Anyways, well, now you know that it's worked properly. Nice. Looks something looks quite repetitive. I can't put my finger on it. Clear. And make that down again. We've generated the data, and well, what else was there? Huh? Huh? Well, cheating. Okay, I'm cheating. Well, we need to know. After we generated the data, we have to do the calculations. Huh? That nice? Ah, I didn't stop. Did not stop. I just closed some window of mine. Find the mean of x, right? So let's do that. Exterminate for that. I just love I. I just love I. Allah. Oh no 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 no. In x. Is that beatboxing or not? Comment down below about that as well. K K K K K K K K K K K R. What? No 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 no. Yeah yes yes yes. I'm complicated. Like what were you trying to find again? Yeah, mx. We have mx down by. Yes, we do. Mx plus equals to plus equal to I. Okay, that's good. And after that, mx by x dot length. Now let's console dot log that. Console dot log x. Oh, yeah, that's what I missed, huh? Don't know why I have so much distraction here. Console, please. Okay. I mean, seriously, where else did I console log anything? Did I do string it or something? Let's try something. Okay, let's see if that does anything. Like, what is this number really? It's confusing me now. Okay, let's delete this and console.log mx plus 10. Okay, and clear the whole thing. What? No, that can't be. How much is mx, huh? Was anyways, really. This is not making any sense. I must have made mistake somewhere. Uh, mx plus equals to 1 mx pi equals to, you know what? Let's just do that and mx, see what happens. I see. But clear. Clear the whole thing. Save. Come on, control or log mx. We have mx right there. Don't. Doesn't make sense. Doesn't make sense. I'm stopping my video right here and trying to figure out something. My verdict is let's just accept this. Really, may not make any sense. May make some sense later onwards. Now we want to find out the same thing for y. So that I in y rhymes. That's nice. My plus equals I. Really, I mean, there's no way to like check my work on JavaScript. So if there is any problem, then please tell me. Okay, please. Yeah, that's done. Now, let's just go back and check what's after that. X deviation. Nice. Bad cat. Stop walking. Doesn't listen to me. X deviation. Now we got the mean of x, so we can find the x deviation. Can't be. For amygdalic, let I in x. So smart move. That's a really smart move. I say that is really smart move. And what we have to do, all we have to do is x dev dot push x dev dot push. What did you have to push? Yeah, I minus m x. See, that makes sense. That actually does make sense. And to the same thing that let's be ydev now. Ydev. Nice, is it? We figured that out. Now let's go back. Really, making things from scratch is not fun. You know what? Maybe I've changed my mind. When you're actually making the video game, no making things from scratch. Got that? I'm sure you did. So stop lying. Oh, xy dev. How could I have missed that? After that's x dev square, y dev square, standard deviation, correlation. I hate correlation. Okay, so for let I in, you can't do that. That's let I equals 0, I less than stop and xy dev and Done. Okay, now we're gonna see if it actually works. I really don't like these kind of for statements. I don't like these kind of for statements. I like these kind of for statements. Console.log xy def. Come on, save. Come on. Why isn't it logging? Huh, odd. Let's find what's wrong in this. There is no error here. Why is it not working? Eh, that is very odd. Let's check if they have something for xdev then. Xdev is there. Seems to be the same. The same. You know what? Mission abort. I am not doing it in JavaScript.
Chutney. Bite, bite. Hmm. Tell me. No beat.
Yeah, mission abort. Anyways, I'm going to do it from scratch in JavaScript. All of this, all the coding will be done on Python now, and I'm going to explain it. Okay. The end. Take two. I am very sorry that I just gave up on like this, but I would like to say that the next video will be on the perceptron. That's a part of the neural network. All of that's going to be explained in the next video. So well, that's tomorrow, I guess. Have fun. Happy coding.